presenting the screen.
Okay.
You're getting
No, sir.
now?
No. Yes, sir. No, right now it's okay, sir.
Uh, so, so I will be like, shall I start now?
Yes, sir. No problem. Start.
Okay.
And then
Most of you have listened to my first lecture where we are talking of cyclone, how they move, and how to means what are the different physical mechanisms which actually cause their genesis and movement. Now, what we will do in practical, we will try to analyze the base track data set and try to understand how to get knowledge out of it, and how we can use simple techniques to understand first and then try to set our hypothesis. So next half an hour to half and half to 1 hour, we will be doing that. So most of you may be having Excel on your computer, so we will simply first level use the Excel, and there is something called as international best track data set, which is IB track data set, which is available free of cost to everybody. So if you go to Google and say cyclone best track data, if you see, you can come up with the UCAR website where data is hosted. If you click there and go to get data and then IB tax data, you will get this data set and you can download data access, and then you can download the data in various format, but better we will download the CSV format. And we have you can download this data. If you want to practice, you can simply click and then you can save that. I have already saved that, so I'll show you. Data is looking like this. So these are the various cyclones which occur since 1842 all over the globe, and this data is available. So anybody can use this data to do the analysis. It can be any analysis where you want to uh, understand the impact of cyclone, then where the cyclone was there or not, that you can find out from here. Now there are many abbreviations, like NI is North Indian Ocean, then AS is Arabian Sea, BB is Bay of Bengal, uh, and then South Indian Ocean, and so on. So if you see, if you go North Atlantic, NA, and so many abbreviations, those details are given on those website. So this can be used. So what information you get out of it is what is the date and time of genesis of that particular tropical cyclone, where it was originated, and which subbasin. NI is North Indian Ocean, BB is Bay of Bengal, and what are their latitude and longitude, how it moved, and this is continuously uh, shown here. And then you can see this first tropical cyclone was from 1842 October 25th till you can see up to November 2nd. So this is a tropical cyclone. So this is a huge data, and you also in your studies might have come up with the such a huge data set, and you need to separate them. So we will just see how to use Excel in effective way to do that. Second thing, we will see that how we can use, like most of the trend analysis we are doing. We can use Excel for those things that I will be saying. Some of you might be already aware, but we will try to use in such a way that most advanced thing we will cover uh, using that, and then try to generate the knowledge. So first of all, what I'm trying to do is I'm trying to create a copy of original data. So I have saved this data as instead of CSV as Excel file, and then data is getting copied. Another sheet will come. Data is used, so it takes time. Uh, just doing. Okay, so our second page is ready now, and we will work on this. Now, first of all, what we want to know is we are interested in only North Indian basin, not Atlantic and other. We are not suppose interested, and that too again we want to know only get the Bay of Bengal data. Ideally, what we should do is we should delete this data, then rest of the thing. But which is not required in Excel. Excel is most powerful, and then you can filter your data. So for that, if you are in Home tab, you go to Data tab and simply filter the data. So once these filters are ready, then what you can do, you remove the select all and only consider North Indian Ocean data. Then you will see North Indian Ocean data only listed here. Then in sub-basin, you only select either Arabian Sea or Bay of Bengal. We will at this moment select Bay of Bengal, and now Bay of Bengal data is there. Now we want to we can see now some of the most recent cyclone was Amphan in May, and all these cyclones are listed and their best track. So for example, if you consider the funny cyclone, this is the funny cyclone track. So if you have GIS, you can plot in GIS or graphs, but if you want to just see that how funny cyclone moved, you can have just select the funny cyclone on the first level and just plot as insert chart as a scatter plot. So you will see that how it moved from you have to reverse the XY. A minute, I will. What you can do is you have to have this as x-axis, and this as the y-axis, because this is latitudes. You can give some series name as track, or we can give funny name of the cyclone and then plot it again. So you will see that how tropical cyclone funny has moved. And if you have actually map version, you can plot a map on that. Actually, I don't have map version. I use grads and all. So you can add map to this also, and you see how tropical cyclone Fani moved from its genesis to dissipation. And you can add data labels if you want, and so many things. Now, this is just to see, explore the data, because most of the time you will not conclude based on the mm, mm, based on without analyzing data, but you need to really look into data before going to have a put forth some hypothesis. So let us have a hypothesis like this tropical funny was developed in 2019 and I think in May. Yes. So 2020 May we have Amphan and whether month of May this tropical cyclone are really going in same way or not, that we want to understand. So whether the tracks in PHN tracks are same or not, or they follow same kind of structure or not, that we want to see. So again we can go x-axis, okay, and again we give y-axis, and then another hypothesis we will try to put forth, that in 1842 there was a cyclone, and there was no name for that, but we assume its name as 1842, and whether in 1842 same kind of track was followed by cyclone or not, which was occurring over Bay of Bengal. So so this is the cyclone where we were. So its x-axis is up to 15, 16, 17, 18, 19. Okay, up to 22. So it is something from, okay, October. So here is change in cyclone is there. Okay, we will consider from here 1877 instead of 42, because which have more track points. To here. And so we have just compared this tropical cyclones which occurred in 1877, then in 2019 and 2020. And you can see these are the tracks. So I have shown you many tracks. You can plot map behind if you can add to that. I don't have map database, so I am not adding that. And we can add a legend to this. So you can see like funny and unfun is this, and in 1877 also track was like this. So what is the difference? If you add a map to it, we can see that if you go up to 15 degree, uh, the India is going up to 40 82 here. So here will be India from about 8 to 82. So there is a pattern which is in 1887. One cyclone is showing that it is recorded over the coastal region. However, if you see the cyclone, whatever the form during recent years, they just recovered over the ocean region. And most of the tropical cyclone, even in 1877 and in 2019 and 20, they recover first went into northwest direction, and then their trajectory is in southeast direction, and most of them affect in the Bengal region. Here somewhere our West Bengal and Bangladesh is there. So this region they have a impact. So if you see the nature of the tropical cyclone, which actually was same, where the first northwest movement and then southwest. Only thing is this particular tropical cyclone showing the curvature over the land and then wind. So what is the consequences? Like I can write a hypothesis like that. Initially, actually, if you see the curvature is taking place because of the changes in the wind pattern uh, in wind pattern at 5 to 5 kilometer to something around 17 kilometer, and that is called as the middle and upper tropospheric winds. Those are steering winds, and they take the cyclone with them. Now, the steering winds uh, are very much uh, have in the sense that the steering winds are very much responsible for their movement. It is something like in supermarket you are pushing trolley from the top, not from the bottom, and that is how cyclone moves. So is there any change we can see? So if you see 1920, the curvature is at little southward than the northward, what was seen in 1877. So whether there is a change in southward shift in the this steering wind, and then therefore the cyclones are recurving much before. So we can have a first level hypothesis that cyclones are recurving uh, much before compared to the uh, mm, previous this one. In 18 means old this 1877 or the previous. So if you can plot that, one of my student did this analysis. So I'm just trying to impress you that in simple Excel you can have a simple analysis plotting them like this, and try to have a this is a hypothesis testing. And once your hypothesis is tested, then we can really go for a uh, better theory development, and then obviously coding and all. So nowadays so many tools are available which really makes it. So first level I am seeing that this recurvature for Amphan is happening from at 10 degree, this is at 12 degree, and this is about 15 degree, and I hope that there is a southward shift of this one. I'm giving you this example because if in I think 2019 there is a paper by, I forgot the author, in Nature indicating this southward shift, and one of my student also published in this climate dynamics in 2018. So this both shows the trend. So what is most important is what how to get the hypothesis, and then there is a southward. There is another paper by professor from IIT Kharagpur in Nature Review. There also it is indicating that they have analyzed for the monsoon this southward shifting of shear zone is there. So southward shifting of shear zone is there is because of what is a question, and which most of the time people try to answer with the climate change. So these are the initial analysis I wanted to show you, and then you can form the hypothesis and then try to do the testing. So this is very simple and most of you can do easily if you have this database. It doesn't take time, and but only thing is you need to understand the theory behind this and doing that. So this is the first level testing of hypothesis you can do and keep on doing. So what I can keep on adding the cyclone one more in between, something like in 1950s we can add some cyclone, and then we can add somewhere in 1980s. Okay, somewhere in 50s. These cyclones are not named, so we will give the name as 1950. And you can see this is October. We'll go for somewhere in May, because most of the cyclones are from May we have selected. Yes, there is something here. And 22, 23, 24, 26. Yes, up to here. Yes. So we have added this. Then one more we will add something in 1980s. Okay, 80. Oh, 80 no cyclone in month of, so 79 latest try. It is there. So month of May. Okay. And then let us see the graph. Yes, see now this should be 79, not change that. So whatever the 19 80 was having some recurvature like this, but if you see 1950, they were recurving here, and then 1987 was here. Now, and again, recurvature is in 1980 was here near to 15. There was a dissipation also here, and 1950 also showing some kind of recurvature and then dissipation. So, so there is a clearly indication that there is some shift happens there. I will tell you the result. Result is that there is a some shift in southward shift in genesis as well as the recurvature point. It is non-result, but if you want to have the hypothesis, first use this simple technique and then try to have the hypothesis, and then followed once you have the hypothesis, once you have this observation, try to understand why it is happening, and then try to go for the physics and other thing then also. This is the simple example where we can say that impact of climate change. Then how to give the explanation, like first level you should have the hypothesis is there is a shift of shear zone and it is coming down, so there will be a recurvature. Now once it is recurvature, I was mentioning in my presentation, somebody from America also says that most of the cyclones which will not hit to North America but go towards the polar region, they slow down and go towards the polar region, and instead of hitting America. So this was seen and already reported. So we can see what hypothesis he has made, whether it is there. Now, if you see month of May, this shear zone is coming because like from the fundamental, coming because of I will open the PowerPoint. We can discuss. Yes. So that shear zone is because of the winds from the westerlies from the northeasterlies at lower level and westerlies from the anticyclone. We will go to the diagram so we understand them. Here, I was mentioning like this anticyclones actually gives ways to tropical cyclones to enter, and this motion of this anticyclone determine where the tropical cyclone will go. This region is called as pole region, and from this tropical cyclone enters. So if this tropical cyclone doesn't go away from its position, then cyclone will go and hit like this. And if this particular anticyclone goes here, then what will happen? Tropical cyclone go and hit like that. So if you see now with this understanding the diagram, you will see that there is some shift. So if you see most of the cyclones were going towards India and then recurving, but because that anticyclone is shifted towards Pacific, then this entry is getting, instead of from here like this, it is getting from here. So you can prove that. Now then you find out the cause why that anticyclone is shifted, and then you will come up with the answer that there is a sea surface temperature is shifted. Now this region was warm, rather this upper region. Now this region is warmer, so there is a change in sea surface temperature. From 1950, means if you have a difference of 1950 to till date, and 80, say 70, 1875 to 1950, that shift in the sea surface temperature is seen. So this is one nature paper. So it doesn't require really lot of efforts, but lot of understanding. That is how most of the climate change papers, which are because we always say nature very difficult and all, but this is published paper, and this analysis is used where only simply they indicated that change in the sea surface temperature pattern is causing the changes in the tropical cyclone behavior. So I hope most of you might have got this database. You can try to find out such a analysis, try to find out, write down the hypothesis, and from there you can have a clear understanding, and that understanding, if you can explain in proper perspective, definitely you will get not nature but very good journal papers. I'm just emphasizing you that most of the time we will say that we don't have resources, I'm not able to do this and all, but start with the simple. So this was the one example I wanted to give you, and then you can filter the database, then you can write down the many hypotheses, because this Excel is available in any computer nowadays. You can have. Now suppose I want to understand uh, year versus how many tropical cyclone cross 15 degree north. So I can have a number filter. I will filter there, and I will say that if this value is more than 15, then you give me the cyclones, and I will write down uh, those years, and years versus those we want year versus those how many are there. So I will make here year list, so 1877, or I will make to some other sheets. I'm sorry, this database is used, so it takes time. So what I want is 1877 and number of points when I have this particular tropical cyclone cross the 15 degree north. So these are the points, and total number of points, if you see, are you can use function count. and there are 66,000 points. Okay. Now these are the total among so many points. 66,000, 6,60,61,000. It has passed. Now, if I want, suppose I will give you one example. In 2000, year 2000, how many points are there which are above this? Then you can have count if now our years is here. So this particular column is equal to and if is 20 2000. And then I want to make it, this should not change, so you can make here dollar and here dollar. Uh, and I will give here range. So from here to here. So from here to so this is the criteria you have given. And in 2000 there was no this one. We can have 2010. Okay, okay. Sorry, I have given wrong range. Range is this yesterday. There is some problem in logic, but if we can give here criteria, then you will get the count. So if you have the year, for example, if you have so many years, mm, data, then you can create the range, and then you can have a count. So range, and you don't require criteria, but you just give the value. So there are 935 points in 2020 which are above uh, 15 2000 above 15 degree north. So you can have 2090, suppose 2019, then you just copy paste this there. Uh, we will just shift range also, we will make the constant, and in this particular thing we will give 2019, this one. So in 2019 you have 4000 points. So what does it means? It means that uh, how many particular, if you consider the 15 degree north maybe the latitude of decurvature, then how many track points you have which actually recurred during that, and then you can have a criteria like that, and then define. So you can use first level Excel to get out uh, the understanding. Then uh, what we can do now is most of you might have a lot of data set which actually have a rainfall and rainy days, and those kind of data set if you have, then how we can have a particular what we mean how we can use that. So this kind of data set you may be having, like you may be having AWS at your Madurai Kamraj University. Now whenever tropical cyclone pass over the particular thing, now this is where the rainfall happen, and that rainfall is measured. So you want to find out the landfall, you can get this data from IMD. I have got now at this moment I am analyzing a data which is not tropical cyclone but extra tropical cyclone, which we call as WD. And I have this data is really available with me immediately, so I have opened that, and you will see that it will have the years, month and date and rainfall. These four fields are there, and these four fields we want to analyze. Just want to know each year how many what is the monthly rainfall, seasonal rainfall, and other thing. Now, in this case, for example, if you take Orissa and above, the most of the time in post-monsoon and pre-monsoon season, the tropical cyclones gives the majority of rainfall. Then, based on that, you can have based on that, you can understand that how what is the rainfall of particular phenomena over that region, and for that, what you need to do is the subtotal. So subtotal you need to use for that purpose. Uh, you can select a single array, and then or the we can say that single array we have selected for a month, and we want to have a subtotal. So change in each month, we want to sum what is the total rainfall, and then do the subtotal. So subtotal will be displaying here. So if you go to first, it will give you grand total. So whatever the rainfall data you have, Based on that, you can have the what is the total rainfall, which is 54,796 for from 97 onwards. Now for each month, if you want, you will see that each month, change in month, because we have given change in month. This is the rainfall, and this is for different years. And if you go to third, this is the actual data, and you will see that each change in month, you will get the subtotal of rainfall. One minute, I will again do it. I will just undo that. Okay, I will select this again. I will show you. You need to have a sum of rainfall and do it. And then this is the year grand total. So you get the monthly total. Now, if you go to here, you will get that details, and this. Now, this is how you will get monthly total. Then you can see that during month of say February, winter season, you will see this is the uh, rainfall occur. You can have here 1997, copy here. Similarly, here 1998, and so on. And then you can divide them, this data, like this. So you will get, okay, during, okay, I will show you here first. So I have, what I have done is here, first I have given the monthly instead data. Instead of that, I can have each change in season. I will undo this again, and I will show you uh, original data. Then each change in year, you have rainfall total, and then you will see that 1997, this is the total rainfall, and 2019, this is the total rainfall, and you simply plot year versus before that we will remove that total this one, so we'll replace total by nothing, and replace also we will get all this thing. Okay, and then you just simply plot the data. Here, and then series minus rainfall, and then years, and then So you have year versus rainfall plotted. Sorry, yeah. And then you simply, I'm sorry, this is little slow. Uh, then you simply have add a trend line, and you will see that there is a decrease in rainfall in this region during these years, and then try to find out the cause for that. So this is nothing but the interannual variation. Now, if you select only particular season data by filtering, and then based on that particular season data, if you did this analysis, then you will get the inter-seasonal variability, inter-annual variability, and you can work on this. So these are few examples I wanted to show where you can analyze the data using simply by Excel, and then go for the better tools to make it, such as models and all. To form a hypothesis, initial level you need to work on uh, a simple tools, and then slowly you can try to use, like, what is the, for example, I was showing rainfall, that in which year particular phenomena cause how much rainfall, you can find out by just subtotaling and other thing, and just using the filter you can find out, the first level track analysis you can do, and then finally you can come up with the hypothesis, and then slowly you modify your hypothesis and go for the good research analysis. For example, running a model, for example, if you want to analyze the
Participants, please stay online.
hello.
Hello, sir.
Yeah, you are getting my voice and all, or it was
Only
disconnected?
now disconnected, sir. Now it's
Uh,
okay.
when it was disconnected, just now,
Just
or?
20-30 seconds.
Okay, okay. So just I wanted to conclude that simple analysis will give you the information about how to put up the hypothesis, and then once hypothesis is there, you go ahead for analyzing bigger data set once you are confirming on the hypothesis. With this, I want to conclude, but I am not sure whether participants are able to download and use that data set, but there's some technique I could show. They may be useful for the participant. If you have some feedback or questions, I would like to answer.
Okay, sir. Participants, the session is open for discussion. Please. Um, sir,
Yeah, dataset web page is IB tracks. It is on Yokar website. I can put it on 19 page. So you can use this dataset web page and definitely analyze. You first build a hypothesis in your mind and see in this dataset, and then try to analyze other data so that you want to find out this thing. Suppose you are doing some biology or ecology, you can marine ecology, you want to see impact on phytoplankton or all. So whether cyclones were passing at particular location during 1870s and now they changed their locations, whether it will impact on particular oceanic ecology or not, that you can study. Or this is how with the data set, or is there any impact of cyclone on ecology, marine ecology, that you can study with this data set. So there are many things. I was just demonstrating some simple techniques which really can be used to first test the hypothesis. Once your hypothesis is ready, then you go for the modeling and other things. So if there is no
yes.
further question, over to you, Vijay.
Sir, okay, sir. Is there any question? Um, if there is no question, uh, on behalf of the UGC Slide Organizing Committee and the participants, we deeply grateful for Dr. Amit sir for his enlightening lecture on tropical cyclone. Sir, your address was unique because the way you have presented the whole things and how to set a hypothesis for a cyclone study is very important. These type of information are very useful for these type of participants. And thank you for your funny experiments, sir. Thank you. I'm sure that the participants got more information on tropical cyclone and how to analyze those data in a simple manner. Mm. I hope some of the participants will contact you for their research work, sir. Thank you, sir. Thank you for
Thank
your.
you very much. Thank you very much for giving me opportunity. And really enjoyed a discussion with all of you.
Sir,
Okay.
we are.
Okay.
Thank you, sir. We are
Thank
very
you.
happy, and we will invite you, sir, some other lectures also.
Oh, thank you.
Thank you, sir. Thank you, sir.
Okay. Thank you.
Thank you very much, sir.